2017 graduate from ENC, and a couple of months in KPIT, stint in KPIT. After that, I soon joined Cisco in January 2018. And ever since, I've been doing security, right? So you know it's security, you can call it cyber security, you call it network security. It's all the same at the end of the day. And what I've been doing is I've been doing some consulting, I've been doing some design and troubleshooting for network security all this while. I've been a speaker for security conferences in APJC, in EMEA, in Americas, and I'm a published author on Cisco.com as well. I've published a couple of papers, and currently, like you said, I am a security architect lead, but I lead Zero Trust, right? And that's why we're here to talk about Zero Trust. So that's about me, all right? So today's conversation is going to be around current trends in network security from the lens of Zero Trust. And then we're going to take a look at why do we need Zero Trust to start with. And then we'll take a look at the Zero Trust approach, its tenants, its types, and then we'll also do a quick case study at the end, right? All right. So let's dive into it, right? So this is how your typical traditional parameter looks. So if you have to put our own GIT into perspective, say this is our campus right here. You have the professors teaching, you have the students on campus, and then you have your, say, servers, protected labs and whatnot, right? So that's the traditional parameter that we are aware of. And this can be extended pretty much to everything, right? It can be extended to a campus, which is for the offices, business enterprises, networks, hospitals, or whatever. So this is the traditional parameter that we know of in terms of networking itself. But what has happened over the years is that this traditional parameter, it has evolved, right? So if you take a look at Internet of Things, there's a lot of things getting added, right? So everything is now trying to talk to the internet. The CC cameras, they want to talk to the internet just because they want to store more data, and having a hard disk on the camera itself is not feasible, right? They need to continuously feed it either to the server for live monitoring as well as to for storages. Another example is at our home Alexa, right? So Alexa is able to talk to, say, your the tube lights and whatnot. So just so it has the control of the entire house, right? Which means the internet is able to access each and everything inside your home, inside your perimeter, and the stuff inside your perimeter is able to access the internet. So that's the first part of traditional parameter, how it has evolved. But then it doesn't stop there, right? Even the users are not within the parameter now, especially with the work from home situation that we are all currently in. We are seeing that even the users who are actually working from home, they are still interacting with the perimeter. They are still trying to talk to the perimeter, but then they are doing it from home, right? So they are either connecting from VPN, they are accessing the office servers. They are still doing all of that, but they're away from the perimeter, right? So which means they don't have the firewall to deal with, which is inside the perimeter. Now it's VPN. And then they are using their personal machines as well, right? It's not just the corporate issued or the laptops or PCs that were issued by the authorities at the campus right now, because you're moving away from the campus. And then finally, the other way that the perimeter is evolving is that we are now putting everything into cloud, right? Because maintaining a data center at the perimeter is difficult, understandably slow. And that's why everything is now hosted on cloud. It's an easier solution. It's plug and play. The organizations save a lot of money with it, and so why not, right? So what happens with this is that you can see from being a typical server user kind of an interaction, now we have evolved it and it's become so big, right? And it's going to only keep evolving. So what happens is the problem lies is with the trust, right? So now that you know that your perimeter itself is so big, and you have to allow interaction between each of these. So what you gotta do is you gotta allow access for the folks to talk between each of these, right? Your laptop at home should be able to talk to a server inside the campus. Your server inside the campus should be able to talk to the cloud service where a particular service is hosted, right? So this is where we are losing control, right? Any user, any device, any application at any location, there's a trust that you are exposing it to, and then you are pretty much allowing access to each of these horizontally as well, right? That's the current problem. And because of this problem, what's happening is the attack surface itself is increasing, right? With the evolution of zero trust, with the evolution of the traditional parameter, what's happening is that attack surface is increasing. So before we had we spoke about the traditional parameter, you only had so much to protect, right? Implement one firewall and you are protecting your entire campus. Now, because your perimeter itself has increased and it has become so big, how do you protect all of this, right? So your attack surface is actually increasing by n folds. So the way to do that, and the other problem with that is with increased perimeter, what happens is the attack surface, since it's increased, if you come across a hacker, if you come across an attacker or even a vulnerability at that point, it's able to get access to each of these because of the excessive trust that we are giving, right? So if you are encountering a malware sitting at home, but then you are still VPNing into your campus, that means you are at the risk of exposing your campus as well, right? Because the malware can travel from your home to the traditional parameter, and from there it can even go to the cloud, and then pretty much your entire network is bust open, and then you are exposing the entire network. So that's the problem with excessive trust. So how do we move away from excessive trust to zero trust, right? So we want to implement what we call as zero trust. We don't want to trust everything and everybody in the network at any location or any device for that matter. So the goal should be to move from excessive trust to zero trust, right? So how do we do that? By doing, so Cisco's way of doing that is by segregating it into 3 types, but then you can take a look at any vendor for that matter, and then you can extend it, right? So the principle, the core aspects of it are going to remain the same. So the first type is we segregate into workforce. So workforce is the devices and the users that are going to be interacting with a particular perimeter, right? So that's your workforce. The next thing is your workplace. So this is the crux of the network where most of the things are located. You have a headquarter office, you have a branch office, you have a campus, you have a hospital. This is the crux of the workplace where most of the things are located. Your internal files are located, your policies are located, and stuff like that, right? So that's the workplace. And the last aspect of it, of course, is cloud. So that's where your applications hosted on the cloud are located, right? So this is pretty much the segregation that we call of zero trust, which is workforce, workload, and workplace, right? So workforce is where you're talking about your devices and the users. Workloads is your or workplace, rather. The second one I want to cover is the network itself, and which we came across as the traditional network, and then finally workload, right? So workload is where your applications sit in terms of cloud. So we need a comprehensive approach to securing all of this access in terms of workforce, workplace, as well as workload. And that's when we pretty much achieve zero trust across your networks, across your application, and across your environment, right? So that's what zero trust is about. So if you have to dig a bit deep into each of these in terms of examples for each of these types that we define, right? It's on the screen. So who or what for workforce is, like I said, users. The examples would be and their devices. The examples would be laptops, mobile phones, tablets, and whatnot. So where do we need to verify? Where do we need to take care of the trust here when accessing something, right? Because these are the ones who are requesting access to either your network, requesting access to your cloud. So that's where you have to make sure that you are trusting. The next part is from where. They can be anywhere. They can be sitting at home. They can be on the campus. within the perimeter, and it's pretty much wide open, right? Because they can be anywhere. Workload, like we covered, is the cloud aspect of it, because this is where your applications are hosted, and this is where microservices, Kubernetes, containers, all of the stuff, the brilliant stuff that I'm sure you have been learning in GIT is coming into picture, right? Because this is where the majority of the applications are hosted. But we need to make sure that even these are protected, right? And the trust verification point for this is whenever they are communicating with other hosts or other servers or users, right? So that's where the trust verification comes from. And from where they are not everywhere, they are just on the cloud. So it can be a public cloud, and it can be a private cloud, and it can even be a hybrid cloud, right? So public cloud is something like an AWS, Google, Azure, and so on. And a private cloud can be, say, a cloud meant for only GIT, right? So that's your private cloud, and it can be a mix of both as well. At last, workplace. Workplace is where your traditional perimeter comes into picture. It can be, say, the things hosted on premises. It can still be your users connecting on the network. It can be the IoT devices that we spoke about. It can be it can be, say, industrial control systems in case of industrial production. And then for this, the trust verification point where we got to implement zero trust is when accessing the traditional perimeter itself. And these are again hosted everywhere, right? It can be, but it's typically within that perimeter of the network. So that's the basics, right? We segregate into 3 types, and that's the basics. So if you have to take a look at the tenants itself upon which the zero trust is built, so our approach is pretty straightforward. So what you got to do is, first thing you got to do is you got to establish trust. So how do you do that? By verifying continuously, right? So what you got to do is, first you have to know what your users are. You have to know what the devices are. You have to basically have that visibility. So the first thing that comes into picture is you got to have that visibility that the administration should, the administrator, network administrator should be able to tell who you are, and then give you the access depending on who you are and what you're trying to access, right? And then the other aspect of it is that once you get access, it doesn't mean that you are always compliant, right? So I can say, using my personal laptop, all good, I'm able to access, say, the GIT network. But then what if after verifying my credential, after I'm getting access, what if malware is affecting my particular laptop, right? So we should be even in a position where we are actually verifying the devices continuously, and we should be able to mitigate that vulnerability if something happens, right? So in a way that once you verify the credentials, your job is not done, right? So that's where I'm getting at. Your job is not done. You have to completely continuously keep verifying the trust, and then you should be in a position to revoke access if need be. So this is what's different in a traditional approach versus a zero trust approach. So in a traditional approach, like I said, if you get access to even a single thing in the network, your entire network is exposed, as opposed to zero trust, because now you are continuously verifying the trust and continuously changing your policies to give the access. Now you have the capability to mitigate something, even if there's a attack that happens, some vulnerability that happens, right? So that's the major difference between a traditional approach and a zero trust approach. And then it extends pretty much, the traditional approach, I said, is extended to only the perimeter, but here there's no limitation of that, right? We extend pretty much to everything. So that's how you do it. The foundations, like I was saying, is these 3. The visibility, the administration should be able to know that who is accessing it, trying to access what, and then they should be able to get visibility into the kind of devices that they are using to access it also, right? We'll take a look at it a bit late. Segmentation, it's pretty standard. Whatever we learned in college, it applies. You have to make sure that your network is properly segmented. If your network is properly segmented, your attacks do not propagate. As simple as that, right? So say the CSE department, and the inside CSE department, just the lab is affected, that malware or that malicious activity from the lab shouldn't go across to the ANC department, right? So that's pretty much what segmentation is. Containment is continuously monitoring and responding to threat. Just because you said now the lab is exposed doesn't mean you keep quiet and do nothing about it. So you should be in a position to mitigate that threat inside that lab, and then you should be able to get the access back to that lab. So we already spoke about this. So preventing risk, gaining visibility, and reducing the surface attacks it's all zero trust about. All right. So here are some examples of how to do it, right? So how do we verify a particular user? So first things first is user. They should have a username, password, right? And then you should be able to in a position that you verify it with two-factor authentication or multi-factor authentication. And the way to do that is, we all know it could be OTP, it could be a push, it could be a phone call, it could be anything, right? It's something that you have to prove yourself, some additional identity that you are giving to the administration. The other aspect of it is being able to understand if it's a device that is personal, if it's a device that is issued by, say, the college, the corporate, and being able to differentiate between them, right? So personal devices are more at risk because you don't have much control over them. If it's an asset that the corporate has given, you have more control over them, right? So you have to be in a position that you know the difference between the kind of assets and the kind of endpoints that the folks are using, and then the device posture as well, right? So we spoke about say anti-malware is installed or not. So you should be in a position to check whether or not a particular software is installed, and then whether or not you allow access depending on that. The least access privilege, it's related to the network, and then where you are segregating and segmenting, and at last continuously verifying. This is something that you spoke about, right? So if it's compromised, then the trust is broken. So if the trust is broken, you have to be in a position to regain the trust. So where do we start, right? We have to always start by asking questions, because zero trust is all about asking questions. Say I am somebody who is getting an access to PC in a particular lab, right? So does that mean I get access to a lab which is located in some other department? I am somebody who's sitting in division A. Should I be allowed Wi-Fi access to division B? Something of that sort, right? So you have to keep asking questions, and that's where you allow yourself to be in a position to implement zero trust, because zero trust is all about asking questions. So you keep asking questions and you keep trying to answer in terms of access. Do we really need to give this access, right? That's how you mitigate most of the problems that are occurring in terms of hacking, right? So is this allowed? Is this device trusted? Is this device secure? Is this device supposed to be accessing this server? Is this user supposed to be accessing this? What kind of access level should this user get? Should they get read access? Should they get read write access? Is this network segmented, and so on, right? So this is zero trust is all about a journey, and the journey starts with asking a lot of questions and trying to answer them. And then these are the products. I won't dive into this, but these are the products that Cisco has to offer in terms of how to implement zero trust itself. And this is, I'm coming back to basics just to cover some more in-depth scenarios within each of these, right? So we spoke about zero trust in terms of workforce, workplace, and workloads. First thing we are going to take a look at is workforce. So for workforce, I'm just flashing a quote here, right? Identity is the foundation of security. I'm sure you all agree that this is the foundation, right? So how do we really put that into perspective? So since you are talking about identity, the first things first is how do we verify that particular identity? It could be, like I said, username, password. It could be a certificate-based authentication, and it could even be something called as passwordless, which we'll talk about at the end, right? So that's some case study that I'm going to show you. How do we verify devices? by doing something called as posture check. So posture check is where you see whether a particular say antivirus is installed, anti-malware is installed, and then make sure that this is, say, a certain level of firewalling is already enabled, and those kind of things, right? So that's one of the ways to verify devices. The other way is, if you are using your personal laptops or personal devices, you need to make sure that the administrator still has some kind of an access to be able to say allow in terms of what's allowed and what's not. And then in terms of enabling access itself, how are you giving it access to your network? Is it through Wi-Fi? Is it through VPN? Is it through single sign-on, which is SSO? So you have to have that access, right? So this is the basics of zero trust for workforce, right? Where identity, it's all about identity. And if we have to talk about workplace, the expectation is on the left, but the reality is on the right? So this is where the reality check comes into picture. The expectations, when we talk about least privilege access or segmentation, this is how it should be, right? So the employees, should it really, are the employees supposed to get access to the building management in terms of CCTV? No, they are not supposed to, right? Only the administration should be able to get it. Are the employees allowed to access the printers? Yes, they should be, right? Should the full-time employees be able to access network resources in terms of servers? Yes, they should be. But should the contractors be allowed that? No, right? So it's again about the questions. This is the expectation, but the reality is, we know the identity in terms of who it is, but what they're accessing is where we are losing control, right? We don't really know, because we are giving excessive trust to the level of access instead of least least trust or zero trust. So least trust or zero trust is basically about least privilege access. And then when I talk about visibility, this is all that it's about, right? So these are the steps or questions in terms of visibility that the administration should take a look at before giving any kind of access. All of these should always be answered, and only then a particular administrator should be giving access to a particular whatever access they are requesting to. First thing is who is requesting access, pretty important, right? How do you do that? Again, certificates, username, password, multi-factor authentications. What, right? What is their role? Are they full-time employees? Are they students? Are they professors? What is their profile? What is their compliance? All of this is important, right? And you can make a decision, type of access decision based on that. Where are they accessing it from? Are they accessing it from home? Are they accessing it from office? Are they accessing it from college? Is important. If they are accessing it, say, from college, it might be, you might be able to give a bit more trust, and you might be able to give a bit more access versus if they do it from home. When are they allowed access? Say if it's a shift-based office, right? You should typically get access only between, say, 9 to 5, or if you are in the Europe time zone, working in the Europe time zone, you should be able to get access only between 12:30 to 6:30, 12:30 to 8:30, right? So when is also an important factor. Say if a student is accessing suddenly accessing the hostel Wi-Fi during the holidays, should that really be allowed? And does it seem like a something that the student is actually not doing, but something somebody else is doing, right? So when is also an important factor. Why are they allowed this access? Do they that's also important, right? We spoke about cameras, we spoke about building management, we spoke about servers. Why should we allow the access to those assets? That's the important. And how much access are they allowed? So this is where it all boils down to. All these other questions that we asked, this is where it boils down to, right? This is with the answers to the rest of them, you are able to answer this final question, which is how much access are they allowed, right? Should they be really given full access? Should they be given partial access? Within partial access, how much access? Or should they be given no access, right? This is what it is. I realize I'm going a bit fast, but do we have any questions at this point? So I am monitoring the chat as well. So if there is some questions, you feel free to ask in the chat. but I'm sure you can request to unmute yourself and ask as well, right? So any questions at this point?
Participants, if you have any questions, you can post your question in the chat box, or you can also ask the questions directly. The mic will be provided.
All right. Thank you for that, Professor.
Thank you.
So we don't have any at this point, right? No questions at this point.
Yeah, I guess, yeah. Okay, there is one question from Vijayan.
All right, a question from Vijay. Can I say zero trust is 100% sampling from audit standpoint? So this is a brilliant question, and it's actually a pretty good segue to what we are going to cover right now. And I hope at the end of this slide, I am able to come back to this question and say whether or not we have answered it, right? So something that I'm going to cover right now is what we call as AAA, which is three A's of identity management, right? So identity access management, IAM, or identity management, IAM, is basics of any identity for that matter. And then these are the three things, right? So first thing is authentication, where you are pretty much verifying a particular entity based on knowledge of that particular identity, right? So it could be, like I said, username, password, certificates, multi-factor authentication. That's the first part. Or it could be something that you are, right? It could be a biometric. It could be your eyes in terms of, say, Face ID and whatnot. So that's the authentication part of it, right? So that's verifying a particular identity. Authorization is the permission, right? So authorization we spoke about in terms of how much access that you are giving it. So every question that we asked so far is taken care by authentication, right? Just by answering in terms of visibility what all you are and how much proof that you can provide me in terms of what you are and who you are and where you are accessing it from, what you are using to access it. The second aspect of it is me as a network administrator, how much access that I'm going to allow you. That's the authorization, and that's the second aspect of AAA, right? The permissions that you're going to give a particular user who's taken care by authentication, right? So authentication, there are three results that there can be. For the authentication, you can either get access accept, which means you are getting full access. You can get partial access, that's the second one. And then the third one is you get no access, right? So in case of no access or access reject, you are not going to do anything about it in terms of authorization because authentication is taking care of it. But then if you are supposed to get partial access or if you are supposed to get full access, authorization comes into picture and the network admin has to make that call of what kind of access you are giving, right? So in terms of permissions. And this accounting that you see here at the end is, I think, where Vijayan is asking the question: is it 100% sampling from an audit standpoint? Accounting is always about audit because when, where, who, what was given, how much access is done and dusted, right? But then you got to keep a track of everything that you are giving access to, because you remember we spoke about continuous trust verification. And accounting is where that comes into picture, right? As a network administrator, I should be able to audit, and then you should be able to continuously verify whether or not that particular given access is still holds good or not, right? So that's the reason we accounting is an important aspect of zero trust, which many people forget about, right? So they implement, say, authentication, good, very good. They implement authorization as well, which is still brilliant. But then you should be, as a network administrator, and be able to audit, and then you should be in a position to sample it at any any given time, and then verify that trust that you are giving to a particular endpoint or particular asset. It could be user, anything, right? So the answer is yes, right? So sampling from an audit standpoint is something that zero trust is covering, and that's one of the main tenets of zero trust. All right, good question. So keep these questions coming. I'll do my best to answer them. All right. So now that we know what the expectation versus reality is, this is the principle of least privilege access, right? I'm just flashing the quote again. Users, devices, and applications are only given the access as well as permissions needed for their role or function, right? So you're taking a look at all of those parameters, all of those attributes, and only then making a decision. And still, even when you're making the decision, we are still making sure that you are giving them the absolute least access that they need, right? A very quick example for that is this: if it's an employee who is providing their certificates in terms of identity, and as well as they're providing their username password, now I think that this is a good measurement for me to give access to my protected server, to my shared services, as well as the internet, right? So this is the decision that I'm making, because I'm happy with the username password as well as the certificate, as well as, say, a combination of multi-factor authentication, and now I'm giving him full access. But you have a contractor there, right? You're seeing that Alice, she's trying to access the network as well, but she's not a full-time employee. She's a contractor, right? So what do I do? So authentication, she is giving only the username password. She's not doing multi-factor authentication. She's not giving me her certificate. So now, as a network admin, I should be in a position to say that I'm not going to give you the access to my protected servers. I'm only going to give you very little access to my shared servers, only the ones that you need access to, because I'm following the principle of least privilege access. But I'm still going to give you the access to the internet, because you still need to, say, Google or try to reach out to the internet or even watch Netflix, right? So you should be able to access everything on the internet. But this is the decision that I am making as a network administrator. But my principle in my mind is least privilege access, right? Because the absolute minimum access that is needed for a particular user, device, or an employee, or a contractor, or whatever, is what I'm going to give. I'm not going to give you a single, even a bit more than what's absolutely needed. All right, so this is an example of how it's done. We have this identity services engine as a product in Cisco, which helps us take care of the AAA that we spoke about. This is just a very quick example. You might not be able to understand all of this, but just to put things into perspective, right? Cisco ICE is the AAA server, which takes care of authentication, authorization, as well as accounting. Endpoints is the users, and then you are trying to access, say, Wi-Fi. That's the router, that the switch, and if it's a VPN, it's a firewall, VPN use case, and so on, right? So access points, that's the network devices. ICE, like I said, is the AAA server, where you are making the decision of giving that access. Identity services, this is where you're going to speak to, say, multi-factor authentication. It could be your external identity, like an Active Directory, or say even an SMS service, and all of those things. This is where it comes into picture. And the second, security services, if you have to put more context into what access they are trying to achieve, that could be done as well, right? So this is, if you have to speak in terms of zero trust for workplace, this is where enterprise network meets with the security business aspect of it, right? So that's what this slide is talking about. The other aspect of it is profiling. I just wanted to quickly flash this to show how it looks for an admin, right? So if you take a look at it right here, in red, I've marked, I'm understanding whether a particular endpoint is an Apple MacBook, camera, or a phone, or a Microsoft workstation. And how am I able to do this as an administrator? Because every endpoint, they always have something that they're revealing, right? So your MAC addresses on your devices, the MAC addresses are always revealing something. When you access the internet, you are revealing that you are accessing it from, say, the Chrome browser, or the Firefox browser, or Safari, right? And then it's also including whether it's a mobile device, whether it's a laptop, and so on, right? So it's all always there. It's just that we should be in a position to understand all of this, right? So these are taken care by what we call as probes. And the example for those, you might have learned a bit about these in terms of what DNS is, what HTTP is, and so on, right? So all of these are always revealing something about the endpoint, which we could leverage to understand what kind of a device it is and then make a decision, right? So if it's, say, I've decided it's a camera, and do I really need to give it access to the entire thing? No, I should be able to give it access only to talk to the cloud server where it's storing and streaming. That's it, right? So that's the kind of least privilege access that I'm going to give based on the endpoint profile that I'm able to do as an administrator. And I'm doing it with the help of a lot of probes, right? So that's what I wanted to cover here. And then this, if you take a look at profiling, and if you bring the if you bring ML and AI into perspective here, then you could do a lot of things, right? So there is this deep level inspection that you could do with the kind of traffic that's going on between a server and the client. You can listen into this traffic and then try to monitor it, and then try to understand what kind of traffic it is, and then you can make policy decisions based on that as well, right? So it's a pretty interesting way to do it. That's what the industry is heading towards, and that's why you see a lot of emphasis upon say machine learning or artificial intelligence, right? So that's where it's heading. This one, I just wanted to give an example as well, is of something called as a BYOD. So BYOD is bring your own device. A lot of offices are nowadays allowing it because the network perimeter is, like I said, evolving, right? So you should be in a position to even allow some personal devices to be able to access some things on the network. But I told you the administration should still have some kind of access, right? So what if the iPhone that you are trying to connect to is jailbroken, right? So that's not really secure. What if your Android phone that you're using is rooted, right? And if there's a rooted phone, you can do a lot of things, as we all know. So should these things be allowed? Of course not. And how are we going to do it? By using an authorization policy with the help of ICE. And we all the things that you see here, right? So is it device encrypted? Is it jailbroken? All those things you see at the right side, they can all be monitored before giving access, right? So that's what I wanted to quickly give an example. So this is an example right here on the screen, right? If jailbroken for an iPhone is set to no, but the pin lock is set to yes, only then it's compliant, right? Only then you are going to get access. If not, you're not going to get an access. So we learned about all of this in terms of all these questions that we are going to have asked, and all these profiling things that we are going to do. What I quickly wanted to cover is you should be in a position to reuse that as well, right? It's since you have so much context now, and you are making decisions based on it, you should be able to share it as well, right? Let's be honest, a particular enterprise may not have only Cisco infrastructure, right? It might have a mixed bag of, say, partners like vendors like, say, Juniper, Microsoft, Palo Alto, so on, right? There are all these networking companies. So you should be in a position to share it, right? Because sharing is caring, and that's where we are able to achieve more, right? If the security devices do not talk to each other, that's not a good thing. You should be in a position to actually share your information, the brilliant information that, say, Identity Services Engine in our case is getting. You should be in a position to share it with the different vendors as well. All right, cool. So that brings us to network. So zero trust workloads. So any other questions at this point? We covered workforce, we covered workplace. All righty. Cool. So the last thing is about what we know as cloud. We spoke about private clouds. We spoke about hybrid clouds and we spoke about public clouds, but then you should still be protecting those as well, right? So you have, I told you this is where you have all the applications hosted. It could be containers, it could be virtualization in terms of virtual machines even, and then it could be bare metals as well if you need some hardware there. You should be in a position to use, understand the aspects of cloud attributes as well, because this is where it's hosted on the internet, right? You are speaking to the internet either in a secure tunnel or secure, say, VPN IPsec link, and you should be in a position to protect even the cloud aspect of it, right? So we have something called as telemetry. Telemetry is where you get information about everything that's hosted on the cloud, and then you still share that context with workload, secure workload, and then you should be able to create dynamic policies around it, right? So you can create policies for VDIs, RDPs, virtualization. If you have to talk about virtualization, you can talk about in terms of anything else that's virtualized or anything that's put on the cloud, and create policies and decision-making skills. You can make decisions based on the applications hosted as well, right? So you could do it with firewalls and security groups, but then you should be even in a position to understand, even to create those policies, right? You should be in a position to understand what those applications are on the cloud. So that's about it. So that's about it in terms of workplace, workforce, as well as work cloud. Workload, right? So that brings us to the we are going to take a look at a minor case study here, but that brings us to the end of the basics of zero trust, right? So that's pretty much what zero trust is all about in terms of its tenets, its foundations, what least privilege access is, and what AAA is, and then the kind of visibility that the administrator should have. All right. Again, so if you have questions, do not hesitate. No questions are wrong questions, right? I realize this is a very, very new topic, especially for those students who are trying to make sense of it, right? So if there are questions, do not hesitate. I'm happy to answer. All right. So the next thing that we are going to take a look at is a case study called as the passwordless authentication, right? So the promise of passwordless is the case study that I named it. So the context to that is we asked a question, right? What do you think of passwords? So who did we ask this question to? We asked this question to Fernando Cobarto. So this guy is actually the inventor of passwords, right? So we have been using passwords all these years, and password, like we keep asking you to change passwords. We keep asking you to say, make sure that a certain complexity is met. We keep asking you to make sure that you're not using the same password on multiple applications, multiple accounts. And that's after taking a look at all of these, right? Fernando actually invented passwords a lot of years back, as you can probably imagine. And now that we as Cisco asked him, what do you think of passwords? He said it's kind of a nightmare, right? Because this gets pretty interesting. If the person who has invented it says it's become a nightmare, something is going wrong, right? So why is it a nightmare? The nightmare is firstly to create passwords in terms of the endpoint, the users themselves, right? They start using, say, their dog's name, their birthdays, their girlfriend's name, and whatnot, right? So that's not a really healthy thing to do. And then from an administrator standpoint, what do they do? It's difficult for them to maintain it, right? Because now that you have created those passwords, the administrator still has to store those passwords, right? And you see on the news now, every now and then, the passwords are getting leaked, the accounts are getting leaked, right? Let alone password, even though, say, your credit card information is getting leaked. So what is secure, what is not, right? So it's a nightmare for the network administrator or the security administrator to maintain them. And then to top it off, they have to manage them also, right? So after, say, every 30 days, after every 60 days, they have to go back and change that password, right? They have to request you to change it the next time you log in. So it's difficult to manage them. And then lastly, it's difficult to secure them, right? So where do you draw the line in terms of security? Like you put it in you encrypt it, you put it on cloud, you have firewalls, but then there's still leaks happening, right? So how much security is good security, right? So it's really a nightmare in terms of passwords altogether. And then the question begs, right? After thinking about all of this, the question begs, do we really need passwords? Right? That's the question that I want you to ponder upon, right? Um, so the answer is yes and no, and I'll tell you why, right? So this is what the passwordless brings into the picture. Passwordless is an authentication that removes the shared secret or something that you know factor, and then relies on something that you have and something that you are factor, right? So let's try to split this and try to understand it, right? So what is something that you know, right? Something that you know, like I said, is your own password in terms of whatever you keyed in it. Like I said, it could be a birthday or whatever you put in there. So that's something that you know. But what if you are sharing it? What if there's somebody who's you are writing it down and you are sharing it unknowingly? What if you are using password managers, right? You are using password managers like on Chrome or on Safari. It allows you to save your passwords, right? Whenever you try to log into facebook.com, you enter your phone number or email ID, and then you enter your password. It'll ask you, do you want me to save this password for you so that you don't have to enter it again? And then you say yes, right? So is that really secure? Because you're storing the password in your Chrome browser now, and you are sharing that browser on so many other devices. Is that really secure? It's one thing to do it for facebook.com, but what if you're doing it for your credit cards, right? What if you're doing it for your net banking account, right? So that's something that you know factor, where you are giving your password. You are actually keying in your password, right? So the password itself is something that you know, but something that you know can always be stolen, right? As simple as that. Something that you know can either be guessed or something, or can be hacked, or can be stolen, right? So that's what something that you know is. But what is something that you are? That's something that you are is a very different ball game altogether, right? Because something that you are cannot be mimicked, cannot be stolen. So what is something that you are? Something that you are is, say, let's take a look at it. It can be your own face, right? Because your retinas are different. It can be your biometric devices. It can be a YubiKey. It can be anything, right? And anything that's unique to you as a human being. That's the something that you are aspect of it, right? So if you get to a state where we are, so now you can see the Aadhaar has already implemented this, right? So every time you try to log into Aadhaar, it gives you a OTP, of course. But then if you still want to do some say transaction on the Aadhaar server, it will ask you for your biometric, right? So that's something that you are and cannot be easily mimicked, right? So that's where the world is heading. The world is heading to a place where you are still going to use your username, but not so much the passwords, because passwords is something that's not safe. It's a nightmare for all the reasons that I shared. And although you are still going to use a username, because we still need to know who even before verifying who you are, we still need to have a common thread. But then the password aspect of it is going to go away. You are going to directly get OTPs and phone calls and the second factor authentication, but then that's of course now going to be tied into something that you are, right? Not something that you know and something that can be easily mimicked. So this is the case study. The current situation is this: there's a username, there's a password, and there's multi-factor authentication. It can be again push, it can be OTP, it can be a phone call, whatever. But then the current situation, we are going to move away from this, and then the right direction to go is passwordless, right? So when a user is trying to access those three things that we spoke about, right? So workload, workforce, or workplace, it's the world is moving towards passwordless. And then how are we going to do this? Like I said, you are still going to have a username, and you're still going to log in, but then we are going to start trusting you as a person. And then along with that, we are not going to forget about zero trust. We are going to continuously still monitor your posture, your compliance, whether or not you still look good, yeah, or something looks suddenly something looks off, or something looks risky or anonymous. Say a finance guy is suddenly accessing HR books, right? Or an employee is or a consulting engineer is suddenly accessing the development servers, right? What if I'm suddenly accessing the principal's office and taking a look at our records, right? So that's something that's anomaly, and that's something that's not shouldn't be allowed, right? Although you have verified that user and the endpoint, you should be continuously taking a look at their behavior as well, right? So that's the direction that we are heading with in terms of continuous risk detection, and then this is how we do it, right? So this is the part where you get to do something as well in terms of testing how passwordless works. And let me ping you the link on the chat, right? So you can do this yourself right now as well. The link is WebAuthorIO, right? If you have a device which has, say, biometric sensor, it could be your Android phone, it could be your iPhone, it could be an iPad, MacBook, anything. You can open this WebAuthor.io. I will do it along with you, right? And I'll try to make things a bit easy, and then so that you understand what's going on. But this is the website that I'm requesting you to go to, right? WebAuthor.io. WebAuthor is the protocol, right? We keep talking about IEEE, we keep talking about IETF, where the protocols are defined as a standard, right? So WebAuthor is one of the standards and one of the protocols that has been defined for passwordless authentication, right? So WebAuthor.io is a website maintained by Cisco, where we are using it for our research on passwordless authentications, right? So I showed it on the screen. I put it on the chat. WebAuthor.io is where you're supposed to be. If you have a phone that's should be able to either do a biometric or a retina scan or whatever, you should be on WebAuthor.io right now. All right, so I am on the website right now. So what we're going to do is, I told you we still need a username. So right now, what we are doing right now is we are trying to register ourselves, right? So even before using the passwordless authentication, you have to register yourself first, right? So Viraj is the username that I'm giving. Attestation, you can give direct, indirect, you can read about it later, it doesn't matter much. And then here, authenticator type, you should be using platform, right? Because platform is where your hardware comes into picture. And then we are using these settings of direct and TPM we are giving some random username. You can give any username that you want, and you can click on register, right? Because this is the first time you're going to register yourself as a user. And now you can see my Chrome is asking me to give my touch ID for my MacBook and saying you are supposed to be giving me your biometric identity so that the website understands who you are, right? So what I'm going to do is I'm going to use my finger and then I'm going to register, right? So now it says it's a success. Now try logging in, right? Because now my biometric is registered on WebAuthor.io. Now it's asking me to use this to log in, right? So every time I want to log in, what I'm going to do now is I'm going to click on login. So now it's saying, give your finger, your biometric details to make sure that you are the right person. So what I'm going to do now first is I'm going to provide the wrong finger just so you see what's happening, right? So it says if you give the wrong finger, it says we are not able to authenticate you, right? That's what it says. And something went wrong, your identity could not be verified, right? That's what it says. And now that's if the wrong person tries to access it, right? So if the right person tries to access this, it will this is the same thing, but then now I'm going to use correct finger, and it says it's a success. You are logged in, right? It says you, instead of using the traditional shades key password where you are using passwords, you are now using a piece of hardware to create a very strong, attested, and scoped credential that is virtually unphishable, right? Which basically means it's very difficult to hack it. And then to do this, we are using web authentication, which is WebAuthn and the framework, right? And these are the credentials that it's that's using. So the date created is today, right? I had done this earlier as a test yesterday, but then today, right? So in terms of UTC, this is the raw ID, this is my public key, and this is what we are using for this, say, creating something that I know factor, right? So that's pretty much the case study is about. Use that link for testing if you want. This is, I told you, we should be in a position to share everything with different vendors as well. So Cisco works with all of these brilliant companies, network security companies out there. These are our partners, right? Without which the internet won't run. And that's pretty much it. So we are at the end of the session. So I think it's 1 hour on the dot. I was asked to speak for an hour. And I realize I've been blabbing for quite a while. So do we have any questions?
Participants, please feel free to ask questions.
All right, I think it's a quiet crowd, which is fine, right? So you can still reach out to me if you have questions. Let me do one thing. Let me drop my email ID on the chat if you need something. All right, Viraj. So this is my email ID. I put it on the chat. If you have any questions, do not hesitate to reach out to me. And I'm still here for a couple more minutes if you have questions.
Thank you so much, Viraj, for your valuable time and sharing your great knowledge with us. It was indeed a great session, Viraj.
All right. Thank you, Professor, and the entire committee, right from Professor Deshpande, Gajendra Deshpande. I saw a couple of familiar names. I saw Padma ma'am. I'm sure the entire crew now is going in the right direction. I like what you're doing with the winter school. Wasn't there when I was a student back in 2017, but I think this is brilliant that you're doing it now. So all the best for the future. You have my contact. It's always great coming back to GIT.
Thank you. Thank you
right.
so much.